Thanks, Dan. Hi, everybody. Thanks for coming this early in the morning. I appreciate it. I'm sure you guys all had a great time last night, and hopefully you did enjoy some drinks and some magic and all that stuff. And thanks for coming so early. I will try not to bore you back into your sleep mode, but let's see what we can talk about today regarding the OSGi CDI integration spec. It's a little bit of a comparison to DS this morning, so that it could, if you're familiar at all with declarative services, I'm going to try to make a little bit of a comparison to put you into the spirit of what we're trying to do with this. So first of all, why would we even want to bother to do CDI and OSGi in the first place? Why would, it seems like a challenge that might not necessarily have much value, but there's some important reasons for wanting to do that. For instance, there's already a developer base out there that understands what CDI is all about. And so if we could just benefit from that in OSGi and put you immediately to be productive in OSGi, taking your knowledge in, well, that's an obvious benefit for you. It's a benefit for your employers too, because they can, task you on those types of projects easily. And second, it's a rather important specification and becoming more and more so over time, because it's becoming the foundation for other specification work in Jakarta EE and also in Java SE, in fact. So many more specifications are using CDI now as their glue. You'll have noticed, if you were paying attention at all to the microprofile project, that CDI is actually the glue between all the specifications. It's one of the underlying base profile specs. So all of the other specs that are built for microprofile are underpinned by their ability to work on CDI. And the reason why that's the case, the reason why it's becoming more prevalent, is because it's got a quite extensive feature set. And so it makes for a very good glue platform. And I work at Liferay, and Liferay has a very large application. I think we're close to 3.5 million lines of code. We have about 1,600 OSGi modules and bundles, but we are also actually Java EE, and so we implement the portlet spec. We have tens of thousands of features that are modular, and you can opt into them if you want to. So we use declarative services heavily early on to decompose our platform into these modules, right? So like it shows here, 99% of all of the development in Liferay is done in declarative services. So it's not going away. We're not doing away with declarative services. So this is not a scenario where we think CDI is necessarily better than declarative services. It's simply that it has a different feature set that would enable us to do different things than we could do with declarative services. Yeah, so why would you want to use anything else? How many people here have used declarative services at all? Okay, so a good portion of you, great. And there's a reason why that's probably true, right? Declarative services is super, super lightweight. If you ever tried to analyze the footprint that DS actually put on your system, it would be negligible, probably in the kilobytes range, right? So it's super lightweight. Declarative services annotations are syntactic sugar that only exists during development time. They play no part in the runtime, and so they have a really low footprint as far as reflection and operating of the system, right? All of the metadata that exists in declarative services annotations is all elided to XML files, and then that's all processed at runtime. So there's no class loading overhead on declarative services annotations. And that's actually a rather important point to make it very lightweight. So all the annotations you'll see in DS are all class retention, and they're processed at build time, right? However, if you decided I want to add my own annotation to declarative services, into the declarative services lifecycle. Well, there's no way to do that because it's a fixed set underpinned with no SPI to extend it, right? And there's no concept of intra-bundle injection. So you can use components and you can create a component that's a service and create a reference and then inject it. And you can do all of that, but all of that wiring is exposed to the service registry. Because the only way that declarative services can do a reference is against a service. And if you want a component to be a reference, it also has to be a service. So that's exposing a lot of your internals to the outside world. Even if all those services are private, the references still exist in the service registry. So you're pushing overhead of your injection into the service registry. And if you have a very large application like ours, where a given bundle might have, let's say 10 to 20 internal wirings in a fairly conservative bundle, you're pushing all of that information in the service registry when it doesn't really need to be there. You're just adding more contention into the registry. So CDI lets you do a whole lot of wiring inside your bundle the way you would expect dependency injection to work, right? It's usually technically private to your application, and that's an important aspect. That brings a lot of value. So CDI, it's extensible, so it has a SPI built out of the box for you to extend its functionality, and it's very powerful. It's an annotation processing engine by default. That's its inherent mechanism, right? The SPI is a mechanism for you to say, oh, I want you to process this annotation and do something with it, and you can do that rather easily. And then it has this internal intra-bundle injection. And finally, yeah, like custom annotations, right? That's a very powerful way to separate concerns into different sets of libraries that you then compose, and then a developer can take the different annotations that they want to use, sprinkle them around in their code, and then get some extra functionality. Yet, when you don't need those, you can just take them out and they don't have any burden on your application. Yeah, so complete internal wiring. So I'm going to take you a little tour through what you would see in declarative services and then move that over in what it would look like in CDI. So here we have what is a normal internal wiring in declarative services, right? So this is a component. It's a normal class. And really, what declarative service purists will say, if you really want to do internal wiring, just, do new. Why would you expose that to the world when that's codes inside one bundle? And yet, if you're a DI purist, you'll say, well, I shouldn't do new because I might want to compose these in a slightly different way depending on the scenario, right? So there's this battle of new. And yet, new is starting to be new again, right? I don't know how you say that, but in the world of Quarkus and ahead-of-time compilation and all those things, new is your new friend, right? It's the way that you would want to minimize the wiring at runtime so that there's no reflection, all that. So it's a debate to be had, but there are valid arguments on both sides of on both sides. So CDI, what that would look like is basically just at inject. Here I'm showing off the constructor injection. This POJO here is the injected bean. And you can do things like making it private, but you can also do field injection and method injection in CDI. But yeah, that's how you would do inject. This is pure CDI, so this is what it looks like everywhere in the world, not just in OSGi. Okay, now creating a singleton instance. And in declarative services, you have component, right? That makes a singleton instance of your component by default. In declarative services, in CDI rather, and this is the This is the OSGi CDI specification annotation. This is not a native CDI annotation. At service just makes this bean class a service of type singleton by default. And prototype scope, how many people here make prototype scope services or have? Okay, only the experts. If you've ever had a problem where you need to create on-demand instances of your services, you know, when you might have to have state, and then you need to kill it at a certain point, consider using prototype scope. That's exactly what it's designed for. So it's a very useful tool for you. And it's very useful in a lot of use cases. For instance, if you wanted to emulate session scoped information in declarative services, you would use this model, right? So how would you do that in CDI? You have a service, and then you say the instances are of type prototype. Okay. So in declarative services, I want to get something out of the service registry. You have the @ reference. That's nice. In CDI, since everything has to be marked as an injection point, and then you decorate it with some other qualifiers. Here we just have @inject a reference. Same thing, so slightly different, but very close to the same thing. Cardinality mandatory, so in DS, when you want to say, I always need one of these things, it's the same as, you know, that's the standard mode, is to just say @reference, and that's a static mandatory reference. In CDI, that's the default as well, right? Single, static, mandatory reference. So what this means in CDI is that your CDI components won't load until the service is available. There's no proxying here. We're not stopping the we are completely stopping the CDI container from loading until the service is available. And this is not a busy loading. It's not spinning. It's not on a timeout. It's behaving exactly like CDI in a passive mode, like declarative services in a passive mode. The CDI container will wait until those and only react on the event of a new service. So that's really cool as well. Okay, so optional. Optional in DS was a thing before optional was a thing in Java. So we were able to take advantage of that notion in CDI. So if you do this exact line in declarative services, you have to consider that this could be null, right? Because you're going to come alive, and then all of a sudden you're going to have a nothing here because you said, well, it's okay, I can run without it. But in CDI, we said, hey, there's a concept for that in Java already. So let's just take advantage of it. Let's use the type system to our advantage. And let's just say, if you're going to instead of referring to it with metadata, let's use the type system to make that same declaration. And that way we have an API that we can work with, and we can, you know, flat map that and do all the things that an optional would give you the power to do. So it's rather convenient. Multiple cardinality. So in declarative services, when you want to get multiple services of a particular type, you just have a reference of type list your service type, right? And in CDI, you have a similar thing. So it's just an @inject reference, list of POJOs. DS gives you the at least one mode. So this is the 1 to n cardinality scenario. I need to have at least one of these things if I want to do anything reasonable. So don't start me up until that's the case. And we have the same thing in CDI. We just have another syntax sugar annotation here, minimum cardinality, and you can set that to any default that you like, which is slightly different than declarative services, because declarative services doesn't give you this capability. You'd have to go back, you'd have to set some target properties, which are cardinality. Here you can just do it right in your annotations. And then now this is rather significant difference between Declarative Services and CDI is that by default, DS, its policy option is, what is the other term? Yeah, but we use another term for that. It's, what is it, Tim? Option, the opposite of greedy. Reluctant, yeah. So it's reluctant, right? So your references are reluctant by default in DS, which means that if at some point you received a matching reference, if you didn't specify greedy, later, if a better match comes along, you won't see it, right? It won't rebind to you, which is sometimes something that people don't expect, right? Because you see service ranking is an important property on your services, right? And you use that to manipulate the system. But if you have reluctant references, which are the default, you might not be obvious to you that that thing won't get rebound to the better thing that you made. This is really important in places where you're trying to build an extensible system where some third party might want to deploy a modified implementation of a given service, right? If you didn't do that, then they're going to have to restart potentially, or they might even have to do something like blacklist the other service in order to get the one. So in CDI, we made this slightly different in that all of the cases I showed you before of inject reference for POJO, they were all greedy by default. In other words, the moment a new service comes along, it will be immediately rebound to you. But if you wanted to have the other scenario where you were behaving as a reluctant mode, then you would sprinkle the syntax sugar on it and say, okay, I'd rather be reluctant in this scenario. And I think that is a little bit more intuitive for the cases where you're trying to be extensible. It is a little bit more overhead on a churn. If you do have a lot of deployment or a lot of change in your system, being reluctant by default is a more advantageous because you're going to have less churn, whereas being greedy is going to cause a little bit more side effect in your system. So you have to kind of make sure that you handle those or you take account for that, right? So mandatory or dynamic mandatory, the combination of the two, right? So if you want it to be dynamic mandatory in DS, you'd set your reference policy to dynamic, and then you'd also make, if it's a field injection, you'd have to make it volatile so that you can make sure that you see the change that occurred on the field, right, across threading, across threads. Whereas in CDI, we again opted to use the type system instead. It's still the same annotations, but here, this is the standard CDI provider type, which is defined to be a single method type that just has a get, and it's guaranteed by spec to never return null. So that's its behavior. And so, first of all, since it's mandatory, your CDI container would never come up if you didn't have a reference. If we didn't have a reference to give your CDI, to give you. But secondarily, once you're up and running, if you call the get on this, you're guaranteed to get something every time. So there's no need to do any checks. And dynamic multiple in DS would be, oops, this is the what they call the not the update, but the replace mode, where you're going to get a completely new list whenever the set of matches changes, right? So you're getting a list every time, and so that you're making that volatile. But there is a mode here called update, where you can have your own list implementation, and DS would just inject the actual instances that you're asking for into the list, and that would be the update mode. In DS, we have we're using the type system again to handle this scenario, right? So you have this provider, but you're putting the list inside the provider. So whenever you get a list, you do a get on the provide, you're going to get the list that's currently there. And then in reference, you have dynamic optional. You have to do these properties here. So you'd have a policy dynamic, cardinality optional, and then volatile. And in CDI, again, we're using the type system. So we have a provider of an optional of your service, right? Has anyone seen the R4 or the R6 logging service that is new in OSGi? It's the best thing ever, okay? It's really, really nice. And it looks a lot like SLF4J API, by the way. So in DS 1.4, we inherited now this new ability to just inject a logger of the of R4 logger into your components, so you don't have to worry about how that gets built up or anything like that. And it does have this quirky kind of reference scenario. This is the only exception that exists in how you use the reference annotation in Declarative Services. You specify that the type is a logger factory, but it actually binds the logger instance on your in the field or wherever you're putting it, right? So that gives you the actually an instance of a logger associated with your component, which is cool. And in CDI, because we have a little bit more power, we can even do that with more sugar, or with a nicer, more refined sugar, and we can do that just with a simple inject. And this is the same logger here, so pretty nice. Now, injecting configuration in your components. I'm not sure if you've seen, normally you see this in your activate method. You pass your config through the parameters of your activate method. But you can actually also have a field injection as of our DS 1.4. And there's several different ways that you can do this. Doing this in CDI is very much the same, except you have to add this qualifier here, component properties. Now, this is what is available now in OSGi R6. These are component property types. This is a type-safe way of mapping your service properties or your component properties into your components, right? So here, this is the DS meta annotation for specifying this type of mapping, right? So it's an annotation. Well, first, so it's an annotation, first of all. So it's config. It's meta annotated with component property type. And I can put my I can define my service properties directly as properties of the annotation, right? So that's very cool. And then I can inject it directly in my DS component as instead of passing just the map in, I can actually pass a real object that has real fields that I can get real typed values from, right? So that's much nicer than having to parse a map and figure out, and do type conversion and all that stuff. Although OSGi has a converter API, but this does it all, takes all that boilerplate away and just passes you an already coerced object, right? So in CDI, we have the same thing. So you can inject that same type as a component properties. But if I go back here, I just want to illustrate the DS version of this meta annotation is this is only run class retention annotation, right? So if you want to use this in CDI, you actually have to add a second meta annotation here called bean property type, and that's really just the CDI version of the DS feature, right? So you can apply this literally in this way. So if you want to make it available to both, you can just double annotate it this way. And then you can pass this to CDI or DS equally. Configuration types and component. Okay, so configuration, right? And yes, you have configuration PIDs. You can use an array of PIDs, so you can actually get configuration from multiple different places. You can set your policy, right? One thing you may not be aware of is that when you use configuration policy required in DS, it makes that required on every PID that you specified. So slightly different in CDI is that you can do the same thing. You can depend on multiple different PIDs, but you can set the policy level per PID, right? So you can say, I really need this guy, but this guy is only interesting if it happens to be there. Otherwise, I'm okay without it. I can use defaults. Okay. Notice that here, this is specifying a single component. I'll explain that in a minute. What the difference is. It'll become more obvious here when I talk about a factory component. So what you might not be aware of is that in declarative services, this component can morph from a singleton style of component into a factory instance type of component. Because if any of these PIDs, or rather, the first one of these PIDs that starts to produce factory configuration instances will cause this component to suddenly become instanceable per factory configuration. So if you've ever been fooling around with configuration files and suddenly you played with the naming and you read online about this dash, and then you can add a name on file install or whatever, and then your components seem to go crazy because now you have 5 of them. And you didn't really realize what was happening. That's probably what happened here, is that your single component that flipped over to being a factory component, or a component with multiple instances, right? So that was slightly confusing for some of our developers, and particularly our third-party developers in our company. And so we wanted to clearly separate that notion. So in CDI, you can't have this. This cannot happen. You have to specify that a component is always going to be a single component, or it's always going to be a factory component. And the point here is that when you specify a factory component, you have to say, I'm only ever going to become a factory when the PID foo provides factory configuration instances, right? But I can also depend on this other PID. So if you also happen to have a bar, I'm interested in those properties as well. Exactly. Yeah. They're completely different. It's considering them as completely different buckets. Yep. All right, so there is much more. I don't even know how much time I have left. Okay. So yeah, there's much more in the spec. One of the things I don't really have, I can't really show you guys today, but I think it's worth reading about, worth mentioning, is that part in the beginning when I talked about the CDI being extensible and being able to add your own annotations. The CDI spec, the integration spec, we tried to do as good a job as we could to make the notion of extensibility of the CDI in OSGi as modular as it should be in OSGi. In other words, you can provide a third-party plugin called a CDI portable extension, which can have you can play with your CDI container and add and extend and add more capabilities. So it kind of works, in a kind of what we call a love triangle. So you have your CDI, CCR is what we call the runtime for CDI, as opposed to so CDI component runtime, and then you have an extension, which is a portable extension for CDI, and then you have your CDI bundle, right? So this is your code here, and it has annotations in it. And you build a custom annotation. And that custom annotation depends on this extension. and this extension has to tell the CCR, hey, I exist. And then the CCR can say, hey, I can give you that extension. And so you can create a bundle that uses all kinds of different added on extensions, and the CCR will ensure that this triangle exists. So you can actually have other bundles that use another extension. I need that extension, so this guy's going to tell that, and that will all work. So it's you can have a constellation. You don't need to do crazy class loader stuff to put extensions inside your bundle or create custom class loaders. All of the class-based management for those extensions is handled by the runtime, and it's a pretty powerful mechanism. So I just want to show you a new little thing that we're doing right now. We did some recent work to add, it's not committed yet. I still have to work through some cleanup tasks with Tim. So we're adding examples of this to en route, or I'm trying to anyways. So the en route project has a very nice application. If you saw some of the other talks, I think Tim might even be talking about this at some point today, maybe? Oh no, he may have though. But this is the OSGi en route microservice example, right? And this uses declarative services, and it uses JPA, and it has a JDBC example, and it has a REST application, so it uses JAX-RS and all that stuff, and it puts it together and has a UI and everything. And so it's a nice kind of comprehensive example. So what we're going to do is we're going to have a mirror of that, which is all based on CDI, so that you can actually see the two things working and how they would differ from each other. And so I just want to make a couple of illustrations of what that looks like. So here's the JPA component DAO object, this is how in declarative services you would use the transaction control specification that Tim Ward wrote, and get an entity manager, and then do, this is the very nice API for doing transaction control, transactions in declarative services or in OSGi, and then you do all your work. Configure the scope of your transactions, all that stuff, very nice. I highly suggest looking through that. Okay, so that's a rough example. And then we have what that same DAO object would look at like in CDI, and I can make a few illustrations here of differences. So instead, I opted to inject a logger. We do the same inject of a reference for transaction control, and we have field injection. So oh, I'm done. Okay, so this will be online very shortly, I hope, probably within the next week, I would say. I don't want to be too aggressive because Tim has to review it, and I want to make sure he gets an opportunity. So we're going to try to get that pretty soon. So look for that. And thanks for coming, and have a great rest of your conference.